This is the final Docker episode of this series, and in this one we'll be discussing about Docker CLI, that is the command line interface. There are a lot of Docker commands. The Docker documentation are extensive but overwhelming when you are just getting started. A Docker image is made of a Docker file plus any necessary dependencies. A Docker container is a Docker image brought to life. To work with Docker commands, you first need to know whether you are dealing with an image or a container. Once you know what you're working with, you can find the right command for the job. Even though there are so many different commands, there are a few commonalities between them. So the Docker CLI management commands start with the word Docker, all small letters, then a space, then the management category, then a space, followed by the command. For example, the command could be Docker space container space stop, which stops a container. A command referring to a specific container or image requires the name or ID of that container or image. A flag with 2 dashes in front is the full name of the flag, and a flag with 1 dash is the shortcut for the full flag name. For example, -p is short for --port flag. Let's look at some of the commands that we need to know. So the general syntax for these commands are Docker space container space my command. So this my command will be changing depending upon what you want to do. Some of these include create, which creates a container from an image, start, which starts an existing container, run, which creates a new container and starts it. So it's a combination of create and start. Then there's ls. For people familiar with Linux, ls is just a list command. So here ls lists running containers. There's inspect. This shows a lot of information about a container. There's logs, which prints the logs of the container specified. There is stop, which gracefully stops the running container. And there is a kill command, which stops the main processes in the container abruptly. And then finally there's an rm, which is remove. So this deletes a stopped container. These were the commands with respect to the containers. Now let's look at the commands which are related to the images. So the syntax would be Docker space image space command. And some of the commands that we must know are build, which builds an image, push, which pushes an image to a remote repository, a remote registry. Generally, this is a Docker Hub. So we generally create credentials for the Docker Hub, and then when we push this, we should have configured the credentials with Docker so that we can push our images to our account on Docker Hub. Then there is history, which shows us the intermediate image information. There is inspect, which shows a lot of information about an image, including the layers of the image. Then there is RMI. So for containers is RM, which is remove, and for images it's RMI. So it's like remove image. So this deletes an image. And there are a few other miscellaneous commands that we must know. These include Docker version, which lists the information about your Docker client and server versions. There is Docker login, we can use this to log in into the Docker registry. And then there is a Docker system prune. So this deletes all the unused containers, unused networks, and dangling images. Now let's look at some of the commands associated with the containers. The terms create, start, and run all have similar semantics in everyday life, but each is separate Docker command that creates and/or starts a Docker container. Let's look at creating a container first. So Docker container create, this creates a container from an image, and we could specify the image at the end of this command. Like for example, it would be myrepo/myimage:/mytag. So we are specifying the repository where our image lies and the tag of our image. So our repository can hold multiple images with different tags. In this one, we are just creating a container. A little more advanced command could be docker space container space create space -a space stdin space my image. So the -a stands for attach. We can attach the container to a standard input, standard output, or a standard error. You should be knowing this if you are familiar with Linux. And then once we have created the image, we can start the container using we have created the container, not the image. I'm sorry. So now that we have created the container, we can start the container by using docker space container space start space my container. So this is the container name that we have chosen while we create the container. Now that we have seen how to create and start a container, let's see the most common Docker command. It combines both create and start into one command, which is run. So we could just say docker space container space run space my image. So we can just specify the image, and when we say run, Docker automatically creates a container from this image and starts it. Now let's look at some of the flags that we'll be using most commonly. So the first one is -i, which means interactive. So if we want to interact with the container through our terminal, we specify this. And we also need to specify the -t along with the I flag, and T stands for TTY. So these two go together. And then we can use the flag -p, which is short for port. The port is the interface with the outside world. For example, if you use -p space 1000:8000, this maps the Docker port 8000 to the port 1000 on the local machine or the server. So the physical server port 1000 would be mapped to port 8000 of the Docker container. If you had an application that output something to the browser, you could then navigate your browser to localhost :1000 and see the output. Then there is, if we include the -rm flag when we use the run command, this automatically deletes the container when it stops running. So when we specify the -rm command, the run command starts the container, and after everything is finished, the container obviously stops running. And as soon as the container stops running, and because we have specified the rm flag, the container gets delete it automatically. sh is a command you could specify at runtime. sh will start a shell session inside your container that you can interact with through your terminal. sh is preferable to bash for Alpine images because Alpine images don't come with bash installed. And then we can type exit command to end the interactive shell session. Now let's talk about the commands to check the container status. We can use Docker container ls to list the running containers. And we can use the A flag, which stands for all, which lists all the containers. So running containers as well as stopped containers will be listed with the A flag. And then there is a S flag, which specifies the size. So we can list the size of each container. So Docker container inspect followed by my container, that is the container name, shows a lot of information about the container. And if you want to see the logs with respect to the container, we can use the command docker container logs followed by the container name, which prints the container's logs. So after we have done with the work that's supposed to be performed by the container, we can stop the container using docker container stop followed by the container name, which stops one or more running containers gracefully. So it gives a default of 10 seconds before the container shuts down to finish any processes. And then we can use a docker container kill followed by the container name, which deletes the container. But before deleting the container, you should make sure that it's stopped. Anyway, Docker will raise an error saying that the container is still running. If you are trying to delete a container which is still running and is not stopped. And then there is a command to delete all the containers that are not running. So it could be docker container rm. Then we need to give the list of all containers which are not running. So this could be done by $, followed by parenthesis. And within these parentheses, we need to specify docker ps with the A and Q flag. So this docker ps A and Q flag will return the list of all the containers which are not running. And then docker container rm, which precedes this command, will take this list and delete all the containers that are not running. Now that we have looked at the Docker commands for the containers, let's look at some of the commands for Docker images. First, we'll look at the build command, which develops the images. So it's docker image build followed by the T flag and the tag for the image. So we provide tags so that we can identify what kind of an image it is. So this command builds a Docker image, which is given a name that we specify in the tag from the Docker file located at the specified path or the URL. The T flag is short for tag. This tells Docker to tag the image with the provided tag. And then this command, the build command, is ended with the period. So this period at the end of the command tells Docker to build the image according to the Docker file in the current working directory. So if you specify period, that means Docker takes the Docker file in the present working directory, or we could specify the path to the Docker file which we need to use to build the image at the end of the command. And then there is a Docker login, which I have discussed earlier. And there's Docker image push, followed by the image tag, which pushes the image into a registry. Now let's talk about inspecting images. The first one is Docker image ls. So this lists all the images. And Docker image history, followed by the image name, displays the intermediate images with size and how they were created. And then Docker image inspect, followed by the image name, which shows a lot of details about the image, including the layers that make up the image. Now that we have seen how to create and inspect the images, let's look at a few commands to remove the images. Docker image rm, followed by the image name, deletes the specified image. If the image is stored in a remote repository, the image will still be available there. So this command will delete the image on our local system. So there's some miscellaneous commands like Docker version, which gives the information about the Docker client and server versions. Then there's Docker system prune, which I've discussed earlier. And then there is a Docker system prune with a flag and -- volumes. So we are deleting all the unused images, not just the dangling ones. And because we're using volumes, we'll also be removing all the unused volumes. Now that I've said something about volumes, so let's discuss about volumes when it comes to Docker. Data in Docker can either be temporary or persistent. Let's talk about the temporary data. Data can be kept temporarily inside a container in two ways. This is done by default anyway. Files created by an application inside a container are stored in the topmost writable layer of the container. You don't have to set up anything. This is the quick and dirty way. Just save a file and go about your business. When the container ceases to exist, your data will also be deleted. And then there is another option if you want better performance for saving your temporary data with Docker. If you don't need your data to persist beyond the life of the container, a TMPFS mount is a temporary mount that uses the host's memory. A TMPFS mount has the benefit of faster read and write operations. Now let's look at the persistent data. Even here we have two ways to persist data beyond the life of the container. The first way is to mount a file system to the container, and with a bind mount, processes outside Docker can also modify this data. Bind mounts are difficult to back up, migrate, or share with all the other containers. Volumes are a much better option to store persistent data. Volume is a file system that lives on the host machine outside any container. Volumes are created and managed by Docker. These volumes are persistent, shareable with other containers, efficient for input and output. They're able to be hosted on remote cloud providers. We can encrypt them, we can name them, and we can use these for testing purposes. Now let's look at how we can create the volumes. So we can create volumes using the Docker file or using a CLI command. Let's look at the volume CLI commands. Docker volume ls lists all the volumes on the host. Docker volume create followed by the volume name creates the volume with the name specified. We can inspect the volume using Docker volume inspect followed by the volume name. And finally, we can delete the volume using Docker volume rm followed by the volume name. And similarly, in the case of volumes, we can use Docker volume prune to remove all the unused volumes. If the volume is associated with any container, you cannot remove it until the container is deleted. Even then, Docker sometimes doesn't realize that the containers are gone. If this occurs, you can use Docker system prune to clean up the Docker resources. Then you should be able to delete the volume. Now let's look at how we can use volumes for persistent storage. Volumes can be more safely shared among multiple containers. Volume drivers allow for storing volumes on a remote host or cloud providers. We can encrypt the contents of the volumes. We can add other functionalities, and new volumes can have their content pre-populated by a container. So this concludes this episode and our discussion on Docker for these series of episodes on Kubernetes and some of the bonus Docker episodes. These were intended for my personal use. So if you think there's something not clear, or if you just want to say hi or give your feedback, you can write to me at kubernetes@sense.com. That's it for this episode. Thanks.